Okay, once again, welcome to our channel and good day everyone. So today we will be discussing a rational integrand by partial fraction. So our given will take this form. So we have a ratio, so wherein we have the n sub x over the d sub x. So before we solve a kind of integrand like this, so let us first recall the different notations. Okay. So, we can consider the fraction as rational function if we have a ratio of all polynomials. So, meaning this is a polynomial numerator and we also have a polynomial divisor. Okay? So, the ratio must be a proper fraction. That means, ang atong numerator has a degree which is less than compared to the denominator. Because whenever the fraction is improper, then first we have to perform the operation of division before reducing it to partial fraction. And then, ato siyang i-rewrite to follow this form. So, if originally this is our given, then we can write it following this form. So, wherein we have the q sub x, or we have the quotient, then the other term is a remainder term. So, this is the remainder over the original or our divisor. So, this is now our new integrand. So, this term here is already a proper fraction because whenever this is the remainder, the degree of your remainder has, or this polynomial numerator here has a degree which is less than compared to our divisor. Now, the proper fraction will be reduced to partial fraction or simpler fractions. And we have to integrate later. So, to reduce to partial fraction, it's done by expressing our divisor in a completely factored form. And these are the types of factor in our d sub x. So first, we have the linear factor. I denote that with LF. And then, our linear factor can also be repeated or non-repeated. So it is non-repeated if our expression ax plus b has a power exactly 1. So this is non-repeated linear factor. It is repeated when ax plus b is raised to power n. So your n here indicates the number of repetition. So your n must be greater than or equal to 2. Now, another kind of factor in the d sub x is the non-factorable quadratic factor. Because if that's a quadratic, so you always have to check because it might be possible that your quadratic factor can still be reduced to linear factors. Okay? And we also have two types of quadratic factor. Okay? So we have non-repeated. So we have a general term, ax squared plus bx plus c, being a factor of our denominator as quadratic, which is raised to power exactly 1. When it is repeated quadratic factor, then this can be raised to power n. So your n has a value which is greater than or equal to 2. So n is an integer. Okay? Now, to reduce to partial fraction, so that would depend on the nature of the factors appearing in the d sub x. For non-repeated linear factor, if this is containing ax plus b as a factor of your denominator, then we can have a partial fraction which is an unknown constant a over the ax plus b. When it is repeated linear factor, say it is repeated n times. Okay, so ax plus b raised to a power n. So, we can have partial fractions involving term a over ax plus b. Then, we can have another fraction. Say, we can use another constant b. Then, that's over. So, actually, you have to increase the power of your denominator. When this is raised to power 1, this will be raised to power 2. Then, the next term will be ax plus b raised to 3. Then, you can have another letter. So, if that's ab, so this can be c. Then, the last fraction will contain a denominator equal to the factor that is appearing in the denominator. So, L over the ax plus b raised to a power n as our last term. So, usaning L, so bitaw. It is actually representing the last fraction in your partial fraction for a repeated linear factor. Now, for quadratic, so quadratic, which is no longer factorable. Because if that's factorable, so you can continue with factoring. But ang atong i-consider dire kanang ato ang quadratic factor which cannot be factored out anymore. So if we have ax squared plus bx plus c, then there is one fraction but actually this is composed of two terms. So ang imong numerator is actually involving the e, then we have the 2ax plus b. This one is the derivative of your denominator. Then the last term for the numerator side is b. So we have actually two terms because kini siya, this is over the original quadratic factor of the denominator or the quadratic factor of the denominator, then plus another constant term over the quadratic. So actually duha ka term. Now, providing the derivative of your quadratic here is actually intended to follow with a u and a du form. No? So this is quadratic with a linear following a du form of our quadratic, while the second term b over the quadratic, this is a term which will contain a pure quadratic expression. Okay? So in the fourth type of factors of the denominator to reduce to partial fraction, so we have a quadratic which is repeated. When it is repeated in times, okay, so these are the terms of your partial fraction. So we have a times the derivative of the denominator. So if we have derivative of the denominator, so that is the 2x plus b. So times a, then plus another term b over the ax squared plus bx plus c. In our second term of our partial fraction, so just increase the exponent of your quadratic factor. So from an exponent of 1, then you can have another power which is 2. So mula na isa ka from 1, then this becomes 2. Now, for the terms of your numerator, since I already have e and b, then I can proceed with c. Then this one is again the derivative of your quadratic factor. Okay, then plus d. Then you can have again a quadratic factor. Then just increase the power. It becomes 3 and your last term will contain a power which is equal to the factor or equal to the exponent that is used in the factor of your denominator. So if this is in cube, so you can stop until cube. If that is n, then you can stop until n. So for the terms of your numerator, we have L. Okay, so we have 2ax plus b. So this is multiplied to your constant L and plus m over, actually pareho rin na siya, maura na siya og denominator. Basta quadratic gani, you must have two unknown constant. Now, the constants involved, A, B, C, up to L and M, correct? They are constants which will be determined later. And there are two ways to solve for the constant. By assigning values to the variable in order to obtain equation involving at least one of the constant. It is best to start with the value which is a zero of the denominator if any for this purpose. No? So, mas maayo ko, no? If there is a zero of the denominator, then you have to start with that value. If there's none, then you can start at any value because assigning value to the variable can be done arbitrarily. Okay? So, by equating also coefficients of similar terms or variables with the same degree to obtain a system of equation involving these constants. A combination of this method may also be used. So, pwede ka mo gamit assigning values or by equating coefficients of similar terms. Okay? So, let's try. Okay, you are asked to integrate when this is the given. So, we are asked to integrate wherein we have a ratio which is 5 minus 7x. So, we have a linear numerator over a quadratic denominator. Now, if this method is not introduced to us, then pwede na nato i-solve, no, using the previous method which is involving quadratic and linear expression in our integrand. Okay, now knowing this, so first that we're going to do is, kung saan na to? We have to check the fraction. Is it proper or improper? So this is proper fraction, so I can now proceed with expressing my denominator in a factored form. So the factors for the 2x squared plus 5x minus 3 are 2x minus 1 with x plus 3. We always have to check with our middle term to check now if this is a correct factor. My middle term is 5x, diba? So we have the x term which is 6x minus 1x. So the middle term or the x term there is 5x. So this is a correct factor to the given. Okay? Now, as to nature, a factor in the denominator here, this is actually, they are all raised to power 1. Because if you have quadratic, kung yung i-factor, so labing siguro you can have 2 linear factors. Okay, so linear and both are raised to power 1. So this is actually case number 1. So under case number 1, how to reduce in terms of partial fraction, so just copy your factor of the denominator, assign an unknown constant like a, then we can have another denominator x plus 3, so another term is defined where we have a new constant b. So we have e over the 2x minus 1 plus b over the x plus 3 as our integrand. Now this integrand is equivalent to the given, is equal to the given. Now next is to solve for a and b. So this fraction, which is this one, is the same as this fraction. So if I'm going to reduce my equation into a polynomial equation, then I have to multiply every term here of my equation with the LCD. The LCD is actually kini imuhang unsa? Imuhang denominator dire. Okay, so when that's distributed, so what is formed in the left end is 5 minus 7x. On the right side, we also have a times the x plus 3 because the 2x minus 1 is removed. Diba? So, plus b with 2x minus 1. So, I mark this as equation number 1. So, it is here where I have to solve for my a and b. Now, when we apply assigning value, it is good to start with the 0 of the denominator as the value to be assigned to our x. Okay. Usa may magkapasero sa atong denominator of a. So, 2x minus 1 can be 0 if x is equal to 1/2. So, I can start with a value of x which is 1/2. And that will be substituted to my equation 1. Okay? So, by assigning value, so I'm using x equal to 1/2 because 1/2 is a 0 of the denominator. If there is a 0 of denominator, then it's good to start there. So, what is the advantage of having a 0 of the denominator? When x is equal to 1/2, so there is a term here which can be eliminated, which is kining imong b term. Because 2 times na lang. 2 times 1/2 minus 1, this is actually 0. If this is 0 factor, then it's good that b here can be eliminated. So, pwede rin nini mo dili apilon. So, we can solve. It will allow you to solve for the value of a. Okay? So, 5 minus 7 times 1/2. Okay? And that is 3/2 if you combine. And that's equal to a. Okay? So, this is 7x. So, that is why we have 5 minus 7 times the value of x, which is 1/2. If you combine, this is equal to 3/2. And this is equal to a, which is, I'm following here. So, it's 1/2 plus 3. Because x is 1/2, then plus 3. Their sum is equal to 7/2. So, if 3/2 is divided by 7/2, then you will arrive at the value of a, which is 3 over 7. Now, the next value that you're going to assign is the 0 of your x plus 3. So, what value of x makes this be 0? So, there is no other value except for negative 3. So, assigning value, x equal to minus 3, assign that to your equation 1. So, if that is minus 3 for your x, so this term will be eliminated. So, di na lang naapilon. Pwede ragdi. Okay? Because that's 8 times 0. Then, we have 5 minus plus 7 times a negative 3. Their sum is equal to 26, correct? Then, we have plus b times. Okay? So, it's 2 times, 2 times minus 3, then minus 1. So, this is actually negative 7. So, you can divide by negative 7 both sides. So, your b is equal to negative 26 over 7. Then, I can go back to this equation to integrate. Okay? So, knowing your a, so, diri na ako gipuli. So, knowing my a, which is, what is the value of a? That's 3 over 7. And my b is minus 26 over 7. So, I can follow the sum rule. At the same time, I have to put my constant before the integral sign. So, 3 over 7 is placed before the integral sign. And I can integrate following a formula of a dx or a form of a dx over 2x minus 1 as my integrand. Now, in my first term, if this is my u, the 2x minus 1, then I have to check my du. My du is to dx, so it's lacking with 2. So, I'm inserting 2 and I have to neutralize it with 1/2, correct? Okay. And what's the formula being followed? That's a du over u. So if we integrate, so this is the result. In the second term, I have minus 26 over 7. My u is x plus 3. Okay, so what's the du? It's dx. So we can directly go with the formula du over u. So minus 26 over 7, the role is ln of x plus 3. So this is now your answer. So I can now add my c for my final answer. So that is how to obtain the integral of our example 1. Now, there's also another way of solving for the constants, and that is done by equating coefficients of similar terms in case imo ni siyang isolve atong constant by using this method. Okay? Now, from this equation 1, okay, so I have to arrange my term. So the terms actually are x terms and a constant term. If you distribute your a here, so this a here is the constant coefficient of x. So the constant coefficient of x is a, and another one is the 2b. So we have two x terms, no? So let us try to rearrange. So if we have 5 minus 7x, so that is equal to, actually, this is ex plus 2bx. And factoring out my x, so this is the constant coefficient of our x term. And if I'm going to group my constant term, I have 3a. Then I also have the minus b. So I group them. So the coefficient of the x term, if I'm going to collect, are actually a plus 2b. But at the left, we also have an x term having a coefficient of minus 7. So we can equate that with negative 7. Their sum is equated to minus 7. The constant term is, we have 3a minus b. So the 3a minus b can also be equated to 5. If either there is no constant term at the left, then we can equate that to 0 if that's the case. Pero naamtay 5, so it's equated to 5. Now, we can solve our a or b by elimination. Okay, eliminating a or eliminating b. But we can also go directly with the value by using our calculator in simultaneous equation in two unknowns. So, from your calculator, so it will contain x and y. So, pareho na that there's an equation containing x and y. So, 1x plus 2y equal to minus 7. So, it's good to follow the same arrangement of terms. So, if you have a term, b term, and a constant, so you take the same arrangement here. And then, you will be collecting the constant coefficient when you input the value in your calculator. So, your calculator will give you a value of x, and we know that our x is your a value, which is equal to 3 over 7, and our b is equal to minus 26 over 7. So, this is just a substitute. So, if ever you're not going to use the assigning of value, so this can be used as an alternate in finding the value of the constant. Now, let's try with another example. So, we will be looking on another nature of factors in the denominator. Always check if the ratio is proper. So, this is in a degree of 2, this is in a degree of 3, so meaning I can proceed with reducing my given in its partial fraction. Okay, first, I can put my denominator in completely factored form. Maybe by removing a common factor x, okay? And we have x squared plus 8x plus 16. This is a perfect square trinomial, and that's equal to x with x plus 4 raised to 2 as the other factor. So, this is linear, non-repeated, while this one, this is linear. When we say linear, the power of x is 1. Okay? So, if this is x plus 4, so this is repeated twice. So, this is case 1. That is why my first fraction will contain a denominator x. Okay? For repeated, so kaduha man, so there's also a fraction which will contain x plus 4, then x plus 4 with a power 2. You have to stop if you reach with a power which is equal to the given. Okay? So, basta linear ganit, tag-usara ka, constant. Okay, now, next is to continue finding the value of a, b, c. So, there are only 3 constants here. Kung sa gani imong degree there is denominator, that's also the number of constant that will appear in your partial fraction. So, degree of 3, we also have 3 unknown constant to appear in our partial fraction. Okay? My fraction here is equal to that, correct? Okay, magigana. So, reducing to a polynomial equation, I can multiply that with the LCD. So, my LCD is the x times the square of x plus 4. Distribute, so there is 2x squared plus 3, which is equal to a, so times the quantity, x plus 4 squared. Okay, then plus, you distribute, so there's still x, but I can reduce the x plus 4 squared. So, that becomes x plus 4. Then last term is c times x after removing the x plus 4 or the square of x plus 4. Okay, so this is now my equation 1 that is formed. So, what method did I use? By the way, if there are only 3 constants appearing in our equation here, so okay ra kayo na if you have to use assigning values. Okay? So, say I have to assign a value. So, the value here that can make our denominator 0 are actually pila ra ka buok? Duha ra. Because kini this is repeated. So, if you have to use a value as 0 of the denominator, this can be 0 when x is also 0. Kani. Correct? Okay. Another 0 of the denominator is minus 4. So, if these are the only 0 of the denominator, then you can look for another value, any value which can be used as a substitute to your x. So, mangita ka, actually, any value, but do not use value which are very large because, magkalisod ka o compute, no? So, I used only a value which is 1 as my third value. Okay, panalitan. I have to start with 0. When this is 0, then I have 3 at the left, correct? When x is 0, then I'm not going to include anymore the term that's containing a factor x because this can be certainly zeros, right? Okay, so I can solve my a value. So, a times, so x is 0, so plus 4, so plus the square of 4. So, this is 16. So, 3 over 16 as the value of my a. Now, another value of x which is a negative 4. So, when you substitute 2 times a negative 4 square, then plus 3, correct? So, what is the result for this? This is 16 times 2. That's 32 plus 3, that's 35. So, we have another value of negative 4. So, if we have a negative 4, so meaning, kining dunay factor nga x plus 4 tanan, di na nina ko apilon. So, that means, so I can solve for the value of c. So, my c is multiplied with the value of x being used, which is negative 4. So, I did not include my a and b terms because these are all a 0 factor. Okay? So, we can have a value of c. Their sum is 35, correct? And it's divided with negative 4. That is why the result for c is equal to negative 35 over 4. Now, using another value 1, I already have the value of a and c, di ba? Okay? So, with 1 as the value of my x, so my left-hand member is 5, correct? That's 5. And we have that equal to my a. I can use the value of a being computed which is 3 over 16. So, if this is 1, so this is 1 plus 4, which is 5 squared, correct? Then plus, we have b times 1 times pila. This is 5 also. So, b times 5, okay? Then plus, your c. Your c is minus 35 over 4, and that's multiplied with 1, which is x, right? So, this is the equation which contains only an unknown b. So, if you simplify this, you can bring the term together with 5. So, 5 minus this term. And this is minus, so we can have plus 35 over 4. So, that's the value of your b times 5. So, you divide with 5. So, you will arrive with the value of b. Okay? Now, using this equation or this expression here. Okay? So, I have to supply the value of my a, b, and c. Okay? So, my a is 3 over 16. So, ako ipuli din. Over x, correct? Plus 29 over 16 over x plus 4. So, this is my b. And plus c, which is minus 35 over 4 over the square of x plus 4. So, this is now my integrand. Now, following the sum rule, and I can also put my constant factor there. So, 3 over 16, then we have a dx over x. So, obviously, the integral of which is ln x, correct? Okay, so this one. If this is 29 over 16 and I have dx over x plus 4, if this is my u, the x plus 4, the du of which is only dx. So we can go directly to the same formula, which is du over u. And this is the integral. Okay, now, in the last term, if this is equal to dx over, because I'm putting my negative 35 over 4 before the integral sign, so this is actually x plus 4 squared. So this is not integrable under the du over u. So we can bring this up, and the power is actually a negative 2. So you will be using here a power rule of integration where your u is the x plus 4. So this is your du. So adding 1, we have the minus 1 as new power, divide with n plus 1. Okay, and that's minus 1 here. So simplifying, so the term is a positive term. I copy the first two terms. So plus, we have 35 over 4, and this can be part of the denominator. So 4 times the quantity x plus 4. So plus c as my answer. Okay, so that's the second example. So I solved my constant using what method? The method of assigning values. Okay, so supposed to be, I have to separate these into 2 parts, no? But, na naman ang atong part 2, ato na lang i-continue. Okay? So, in example number 3. So, by the way, in the second example, you try to solve the limit, the value of the constant using what method? The equating of coefficients of similar terms, no? So, suway lang ito siya practicing. Okay, so number 3. If my given is the integral of 2x squared minus 3x over x cubed plus 8, so always check, is your fraction proper or improper? Again, this is containing a degree of 2. And this is a degree of 3. So, meaning this is a proper fraction. I can proceed with the expressing my denominator in a completely factored form, and it's good because there is a specific pattern and there is sum of cubes for my denominator. Okay, so these are the factors of my denominator. Using the pattern, which is this one, the sum of cubes, so we have the cube root of the first and second term, so we have x plus 2, their cube roots, and we have the square of the first term. Then we have the opposite of their product. So 2x becomes minus 2x. Then the square of the last term, which is 2 squared, which is 4. So these are the factors of your denominator. By the way, your first factor, if you have to look on the classification of factors appearing in the denominator, this is linear because the power of which is 1. Then this is raised to power also, which is 1. And this one, this is no longer factorable. This is quadratic. Okay? Quadratic, non-repeated also because the power here is exactly 1. By the way, in a quadratic factor, if you are in doubt whether it is factorable or not, isolve lang iyang 0 ini. If you arrive with a 0 which is an integer or a rational value, di na ito irrational, rational value, meaning ratio of integers or integer, so meaning that is factorable. So you have to continue looking for the factor of your quadratic. Again, akong balikan. So to find out whether your quadratic is factorable, you solve for the 0 of this. You can easily look for the 0 of a quadratic by going into your calculator. You solve for the roots. If the nature of the 0 of your quadratic is rational number, an integer or ratio of integer, meaning it is factorable. But if the nature of the 0 of your quadratic is not classified as I mentioned, meaning it's no longer factorable. Like irrational, like values which are non-terminating, non-repeating, imaginary, correct? So, dili na siya factorable. And kini siya, this is no longer factorable. So, I have to follow on how to reduce this in terms of partial fraction. Okay? So, we have this as the new fraction, and this is the partial fraction using the case number 1. Linear, non-repeated. Okay, so this is the first fraction that I have. For quadratic factor of the denominator, I copy the quadratic denominator. I consider an unknown constant. If I already have A, so I can continue with B. B multiplied with 2ax plus B. Actually, it is the derivative of your denominator which is multiplied to this unknown constant b. That's 2x minus 2, correct? Then plus c. Okay? So, this is now your partial fraction, only we do not have the value of a, b, and c. Now, with this problem, now, so we can solve our a, b, c by assigning value, or if not, pwede ka magamit o equating coefficients of equal powers of the variables. Okay, in solving for a, b, c, okay, I copy my fraction here, which is equal to the new fraction being provided in a partial or in a simpler form. Okay, so we have a over x plus 2. Okay, then we have plus a fraction with a denominator of x squared minus 2x plus 4, then b times the 2x minus 2 plus c. Reducing this equation, a fractional equation, into a polynomial equation, so I have to multiply with the LCD. When you look for the LCD, so just copy this expression of your original denominator in factored form. Let's say LCD. Okay? So, this is out. What is left are the terms in the numerator. 2x squared minus 3x from the numerator. Then, that's equal to a. Removing your x plus 2, we have a with the trinomial. Correct? Which is x squared minus 2x plus 4. Then, removing the trinomial, then what is left is the x plus 2. So, we have the numerator, b times the 2x minus 2 plus c, multiplied entirely with the x plus 2. Call this as equation 1. Since I'm already using the method of assigning values in the first and second example, so I'll be using the assigning values and finding the value of a, b, c in this third example. Okay, so from equation 1, okay, so these are the terms of my equation 1. Okay, now I cannot identify exactly the coefficient of every term like x squared, x term, and the constant term. So I take the product, I try to distribute my, okay, so gini, it's okay, I can determine the coefficient of x squared even if di na ko itinagsa og distribute. But dire, if I'm going to distribute this one, no, kung ato nang i-distribute diha, so that means that b will be multiplied to the product of 2x minus 2 and x plus 2. Okay? So, 2x minus 2 and x plus 2, if multiplied, we have 2x squared. Okay? So, this is pila. 4x minus 2x, so is positive 2x. The product of this constant is minus 4. Din c times the x plus 2. And again, pwede na siguro kung mag-identify sa coefficient even if I'm not going to group the x squared term, the x term, and the constant term. So, I can go directly with collecting the constant coefficient of x squared. So, from the x squared term, the coefficient of x squared term is a from this term, correct? I also have another x squared term where the coefficient of that is 2b. There is no other x squared term, so that can now be equated to an x squared term at the left, where the coefficient of which is 2. So, this is my x squared term equation. Okay? X term. X term. I have an x term from this group and it contains a minus 2a as my constant. Nya dire, I have also an x term which is 2b. Correct? I also have an x term here which is cx. Right? So, the coefficient of that is c. Now, that's equated to an x term or the constant coefficient of the x term at the left, where the constant coefficient of which is minus 3. Correct? Okay. So, constant term. Okay. So, ang atong constant term here is we have 4a. Correct? I also have minus 4b. And I also have plus 2c. But there is no pure constant term at the left. That is why it's equated to 0. From system of equation in 3 unknowns in our calculator, then we can have this evaluated. This is actually x, y, z. Okay, so but you take the arrangement for x, y, and z equivalently. So your a is your x, no? And your b is taken from y in the calculator. And your c is equal to a negative 3/2. Adto ka sa equation, system of equations, or simultaneous equations in 3 unknowns from your calculator to evaluate this value. Now, after knowing this, you can go back here. Okay? So, 7 over 6 for your A. Diba? So, 7 over 6, integral of dx over x plus 2. Then, 5 over 12 for your B. So, 5 over 12 for your B, put that before the integral sign. So, you separate this into two terms. Okay? So, we have, pila? 2x minus 2, when this is x squared minus 2x. So, this is already provided with a du form. When this is our u, so this is our du. Okay? So, that's the purpose why we have a derivative of our quadratic derivative that is being provided at the start. Okay? So, minus 3 halves for c. So, this is your c term. When 3 halves is there, so what is left is the dx over the quadratic. So, dx over the quadratic. These two are already integrable under the u du form. Correct? So, this is the du and this is our u. So, we have the same formula. So, 7 over 6 ln of x plus 2. Then, plus 5 over 12 ln of x squared minus 2x plus 4. Now, for the last term, because this is purely quadratic, then I can reduce my quadratic into sum or difference of two squares. So, this is already discussed in our previous topic, integrand containing quadratic expression, where we can write this into sum or difference of two squares by completing the square. Now, it's good because this is 1. If this is 1, then we can only consider the constant coefficient in our x term. Divide this by 2, and the result is minus 1, and put that into square. I have 4 in my original expression, so 4 will be subtracted by the same term, which is the square of negative 1. This is a perfect square trinomial. And if that is a perfect square trinomial, then we can write it as x minus 1 squared. 4 minus 1 is 3. Okay? So, this is already okay. So, I can look for a formula for this term. This is u squared plus a squared, correct? So, if that is u squared plus a squared and my u is x minus 1, the du of which is dx. So, meaning I can go directly with the formula. What formula? Number is that? That is the I-19, which is the integral of a du over u squared plus e squared or e squared plus u squared, which is equal to 1 over a arctan of u over a. So, 1 over a, what's our a? If this is a squared, the square root of that is your a, which is square root of 3. So, 1 over the square root of 3, arctan of u, your u is x minus 1, then over the square root of 3 plus c. So, this is now your final answer. Okay? Then we can simplify, by the way, by multiplying 3 with 1, 2 with the square root of 3. So, to arrive with that as our final answer. The last one, okay, so this involves, now if you try to look at the factors in the denominator, so I don't need to express this in factored form because the given is already expressed in factored form. So, diretso na tayo with our partial fraction. Examine the nature of factors appearing in the denominator. X squared doesn't mean as quadratic, but this is linear repeated twice. Okay? So, I can now give my partial fraction. So, first term is containing a denominator x and that's repeated twice. Correct? So, x, then the second term will contain x squared. That is from the first factor, which is x squared. Okay? So, from linear, tagsa na ka constant. So, we have a, then followed with b. Now, in the quadratic factor, which is repeated twice. This is repeated twice. So, this is case number 4, correct? Okay, so we have x squared plus 1. Okay, and you have x squared plus 1 square. You stop when their power are already the same. Okay, so in every fractional term involving a quadratic denominator, there are actually two unknown constants which will be provided. Since I already have e and b, then I can proceed with c. My first constant will be multiplied with 2x. 2x is actually taken from the derivative of the denominator. Derivative of x squared plus 1 is 2x. Then plus a pure constant term. Okay? The same. So we have unsa? X squared plus 1. So raised to 2. And my numerator is the same as this. Only you will be using a different letter. So if I already have d, then I can continue with e and f. Correct? Okay. So this fraction is the same as the original. This is the same as 1 over this denominator. I am now going to solve for the constants. And there are lots there. So 1 over the x squared times the x squared plus 1 square. So that's equivalent to this one. Multiplying with the LCD to produce a polynomial equation. So what is left at the left hand member of the equation is 1. Then we have a times, okay, so these are the terms, right? X with the square of x squared plus 1. Then plus b, we can eliminate the x squared. So we have the square of x squared plus 1. Then plus this term. Okay, so we can reduce, but there is still x squared. Okay, with the x squared plus 1. Then the last term is, removing this, there is still an x squared that is left. Okay? Now, to identify, no, if there are several constant appearing in our equation, and there are limited number of zeros of the denominator, ang maayo gid nimo ini nga method gamiton to solve for the constant is by assigning values. Do not use the not assigning values, but the equating of the coefficients of similar terms. No, ayaw assign of value, because if you will be assigning value, the only value here that can make the denominator is 0 is x equal to 0. So, usara ka values sa constant anak mo imong makuha. And if you will be using other value other than 0, then all other unknown constant will appear in the system of equation. So, madugay-dugay ka na mag-solve, no? Okay lang kung makaya sa imong calculator. So, the best way for you to arrive with this constant is by equating coefficients of similar terms. So, before that, I have to expand this to determine really the coefficient. Okay? So, if I'm going to simplify first because I have a hard time to determine the constant coefficient, by the way, the square of my binomial here is x to the 4th power, correct? Plus 2x squared, then plus 1, then when x is distributed, then I arrive with this as the product when this is expanded and that is distributed. So, this is supposed to be the expanded form. Kini. Then, x is distributed. That is why this is in 5th degree. That is in cube. And that is in 1st degree. Okay? So, that is b times the expanded form. Okay? Then, 2c. This is 2c. Because, kini ato sa ning i-distribute. This is x to the 4th power with x squared. Correct? And, you distribute your x. So, that is x to the 5th power. Okay? Then, we have x cubed. Correct? Because this is originally x squared and there is x that is being distributed with a constant coefficient of 2c. The d term is also to be distributed or to be multiplied with the product of these factors. We have x to the 4th power plus x squared. I hope you can follow. And this one, this is plus 2e, correct? With x cubed. Is that right? Then plus f with x squared. Okay, so siguro we can now identify the terms. The terms here are actually in 5th degree or x to the 5th power nga term. Okay? So, ayaw gamit og assigning values if there are lots of constants to be determined and there are only few zeros of the denominator. Okay? In this case, there's only 1 zero of the denominator. So, we can use this as a method of solving. Okay? So, in the x to the 5th power nga term, the coefficient of the x to the 5th power, the constant coefficient, I'm referring to that, is a. Correct? So, I'll be looking for another term which is involving x to the 5th power, which is this one. And that's 2c, plus 2c. No other x to the 5th power term existing in this equation. So, that is to be equated to x to the 5th power term at the left. But it is also missing. So, it is equated to 0. X to the 4th power, there's none here. But I have here. So, the coefficient of which is b. Okay? There is no x to the 4th power, but I have here, which is d. Okay? There's none. Okay? So, it is also equated to 0. In cube, I have 2a. Correct? This is 2a. So, that's 2a. What else? In cube, wala dire. There is no cube here, but I have a cube here, which is having 2c as the coefficient. Okay? Then, cube. There's also 2e. Okay, there is no other term in cube. And if I'm going to look for an x cube at the left, there's none because this is only a pure constant term 1. Okay, so this is equated to 0. This may look simpler if I'm going to divide with 2. So, a plus c plus e. That's equal to 0. X squared term. Okay, again, I have 2b. Diba? 2b from x squared. There is no x squared term here. there is d term, or there is d from the x squared. Okay, that one. And there is also f. So 2b plus d plus f will also be equated to 0 because there is no x squared term there. X term, I have a term or ex term, correct? So ex, there is no other x term, correct? So which means this is equal to 0. That means I already have a value of my a. Is that correct? Now, ari ko sa constant. Sa constant term, so a term that is free from x, correct? So this is a pure constant term, 1. Okay? So that means that is b. So, b as a constant term and there is no other term that is free from x dire. So meaning, it is b that is equated to 1. So, e and b already have a value. And as you notice, no, sa atong mga equation na porma dire, so dili tanan nga mga unknown constant ni appear, no? So I can substitute, I can apply back substitution process. So if I'm going to consider my a being 0 and I can substitute here, if that is substituted here, then I can arrive with a value of c which is 0, correct? Because if that's 0, then c will also be 0. So there are already 3 constant being determined. So I'll be looking for another equation where I can solve for any other constant. Okay? So, a, so ari ko nota sa d, this one. If my b is 1, transposing 1 here will give you d which is negative 1. Okay? So, next. This one, this is 0. My a. My c is also 0. So, how about your e? That's also 0. So, last, kini na lang. 2 times b, which is 1. So, this is 2. My d is minus 1. What is 2 minus 1? 1. Transpose, so that's minus 1. So, kompleto na ito ang constant. Okay? Now, in order to integrate, so, I'll be considering these terms for integration. My a is 0. B has a value. C is 0. Correct? My e is 0. So, these are the only terms to appear in your integrable forms. Okay? So, we have this. So, knowing our a to be 0, so, dili na ako si apilon. So, wala na. So, I can start with b, which is 1. Correct? 1 over x squared. My c is out also. Wala na ni. So, I have my d. So, d over x squared plus 1. So, minus, this is out. So, we have minus e. Correct? Ay, minus 1 for f, I meant. So, e is already 0. So, it is minus 1 over the square of x squared plus 1. Okay? So, kini, this is integrable under a power rule. I bring that up and use a power rule. This is actually I-19. So, this is u squared plus e squared. Y a is 1. 1 over a, arctan of u, which is x over 1. So, these two are the integral of the first and second term. Now, this last term is actually not integrable directly. I can use another method of solving this. I can use a method of trigo substitution. Okay, so by trigo substitution, okay, so identify the case possible to use. That is case 2 when it contains a squared plus u squared. So, my u is x. My e is 1 because this is a squared. So, 1 tangent theta. Correct? dx, I need to find a replacement of this. That is a square of secant theta. D theta, correct? So, the whole expression can be substituted by constructing a right triangle. Okay, so here is my right triangle from the first trigo function that I have. Correct? Okay, which is this one. Tangent theta is equal to x over 1. Tangent theta is opposite. The opposite side is x. The adjacent side is 1. So, I need to know the hypotenuse of my triangle. Correct? Okay. So, the hypotenuse of my triangle is the square of x plus the square of 1 or x squared plus 1. Take the square root is my h. Correct? Then, I have to form a ratio. The hypotenuse, which is the square root of x squared plus 1, over a constant. And what trigo function is that when we have hypotenuse over adjacent, that is secant. The product of 1 and secant is equal to the square root of x squared plus 1. Now, I'll be looking for the square of x squared plus 1. So, what would be the power to be used when I need a power 2? Okay? So this is raised originally to power 1/2. In order to have 2, then this will be raised entirely to the 4th power. Correct? So that is the square root of x squared plus 1. So this must be raised to the 4th power because half of 4 is 2. Correct? So, para mo gawas ni. Okay, and that is equivalent to the secant to the 4th power. So I can now substitute to the given, to this expression I meant, no? So substitute, we have a dx which can now be replaced with the square of secant theta, d theta, and my denominator is a secant to the 4th power. Reducing, this is secant squared, correct? And that's equivalent to a square of a cosine theta because this is in the denominator side. This is not integrable when this is a square of a cosine theta, so I can look for another trigo identity using the power reducing formula. Yeah? So that's 1/2 plus a 1/2 of a cosine to theta d theta. In my first term, that is integrable. That's 1/2 theta. Kine, if my u is to theta, my du is to d theta, so I can insert 2 and neutralize with 1/2. That is why the 1/2 here is duplicated. This is a neutralizing factor assuming that 2 is inserted and neutralized with 1/2. Okay? So integral of a cosine to theta is sine to theta plus c. Now, before you restore the variable, I have to go back to an angle theta by using the double angle identity. The sine to theta can be 2 sine theta, cosine theta. So this is reduced back to 1/2, no? So we have 1/2 theta. Okay, then this one, okay, this is being restored, no? So sine to theta, the sine to theta is opposite over hypotenuse. That is why we have x over the hypotenuse of the square root of x squared plus 1. Then cosine theta is 1 over the adjacent side over the hypotenuse. Their product is already x squared plus 1, correct? So that's times 2 because of this. So this is entirely x. So this is equivalent to this one, which is only part of our answer here, correct? So if this is our original answer where I need to find the value of this term, okay, so mo niya to ma-arrive. So if we have this one, these are the first two terms formed, and this is the result when we apply the trigo substitution for this expression. We have 1/2 plus the arctan of x plus, okay, x over 2, then multiplied with x squared plus 1. By the way, these terms are similar. So if I have minus 1 and I have minus 1/2, we can combine them as minus 3/2. And this is also a negative term, no? So there you arrive with a final answer. Okay, so reminding you to, okay, subscribe if my time, no? And thank you for watching. By the way, this kind of problem, no? Pwede na ito ni siya masolve by using the trigo substitution directly. So, suway-suway, so for purposes of reviewing. Okay, so thank you for being with us, no? Watching, and I hope you gain something new under this topic being discussed. So good day and bye-bye everyone.